Hi everybody, this is Eduardo Suarez. This video is part 2 of a series of videos dedicated to iRPickTool with the pre-grouping add-on option package. In this video, we're going to continue from where we left on the last video. To recap what we have done so far, we configure the layout of the work cell with the two robots, the pre-grouping robot and the not pre-grouping robot. We set up the user tools for both robots. User tool number 1, that's going to be the suction cap, and user tool number 9, that is a pointer. We added the infeed conveyor and the outfeed conveyor, and also we added the parts that we're going to need for the iRPickTool setup. On the robot side, we set up the IP addresses for both robots. We configure the robot ring using RIPE, and we set up the encoders on both robots, and we verify that the encoder counts have the same values on both robots. The next step is going to be setting up the iRPickTool. For that, we're going to use the flow diagram that I have already showed you, and we're going to use this diagram as a guideline. I came up with this diagram as a way to explain the relationship that we have between the objects as we set up the parameters. What we have on the left is the tree view that you're going to see on the iRPickTool setup screen. We're going to start by setting up the tree from top to bottom, but you're going to see that configuring the parameters of the object is not a linear flow from top to bottom. Instead, it's going to be more like a back and forth between the objects, as I'm going to explain you as we progress through the configuration. You might have already noticed that we have new objects that we didn't have in the previous videos. We have two grippers. We have gripper 1 and gripper 2, and that's because we have a different user tool number 1 for both robots. So we need to configure two different grippers. We're going to have a tray. That's going to be the virtual tray, where the pre-grouping robot is going to place the parts on the pre-grouping conveyor. And also we have a pre-grouping conveyor that, although physically is the same as the infeed conveyor, on iRPickTool we need to set it up as a different conveyor. We're going to go back to the work cell. We're going to select robot 1, and we're going to select Internet Explorer. The robot homepage is going to open up, and from here we're going to select iRVision iRPickTool, and we're going to select iRPickTool Work Cell Setup. Also remember that if you open the Teach pendant, you can go to Menu, Setup, and open the same page from the iRPickTool option in here. As I mentioned earlier, we're going to start from the top. We're going to select the work cell, and on the setup screen, we don't need to make any changes. We're going to select grippers, and we're going to create a new gripper. For that, we can select from here the Edit Tree and Create, or we can select this plus button over here. We're going to give it a name. We can just leave the default name. We're going to press OK. And this gripper is going to have a zone. It's going to be zone 1. It has only one zone because gripper is picking up one part at a time. Over here, you can set the peak delay, the press delay, and per present delay. We're not going to make any changes over here, but in your real application, you need to put some values in here. Now we're going to select the Zone 1 object, and on the Zone toolbox, we're going to put the same parameters that we have for the user tool number 1. That's going to be 79 for the Z and 180 for W. Over here in the Zone Activation IO, you need to set up the output, and also if you have a sensor for per present, you need to set up the per present sensor on the input. We're going to select grippers again, and we're going to create another gripper. We're going to call it gripper 2. Automatically it's going to create a zone, and we're going to select zone number 2. And over here we need to set up the parameters for the user tool number 1, that we have on robot number 2. That's going to be 93 for Z and 180 for W. And with this, we have set up the gripper number 1 and gripper number 2. If we go back to the diagram, you're going to see that once we have set up the grippers, we can set up the gripper parameter on robot number 1 and also robot number 2. We're going to continue configuring the tree. Now we're going to select the robots object and we're going to create 2 new robots. We're going to create robot 1. We're going to go back to robots and we're going to create robot 2. So robot 1 is going to be our pre-grouping robot and robot number 2 is going to be the non-pre-grouping robot. We're going to select robot 1. Over here, we're going to select the controller. That's going to be robot 1. Group number is going to be 1. And here we need to select the gripper. That's going to be our gripper number 1. We don't need to worry for now about the dynamic error adjustment. We can leave it as it is. And we can select robot number 2. You're going to notice that we're getting a green check mark on each one of the objects as we progress, and that means that the object is a train. For robot number 2, we're going to select the controller and we're going to select the gripper number 2. Now we're going to select the tray object and we're going to create a new tray. This is going to be our virtual tray. We're going to press OK, and over here we need to create a tray by adding the cells. I'm going to show you first how the tray is going to look like. For that, we're going to go back to the work cell and we're going to measure the part. I can take the dimension from the CAD drawings, but we can also do that using the measurement tool. We're going to select the in-feed conveyor. We're going to select the part carrier in feed. We're going to select the parts tab and we're going to make the battery visible. The orientation of the part is going to be on the X direction, on the same direction of the flow of the in-feed conveyor. And we don't need to add any offset. So we're going to press OK. Now we're going to select the measurement tool. We're going to select from the conveyor belt to the edge of the part. And for Z, we have 17.5 millimeters. For X, we have 26.5 millimeters. And for Y, we have 46.5 millimeters plus 2 millimeters for the connector in here. So that's going to give us 48.5 millimeters. Now we're going to build our tray. The tray is going to have 2 layers. Layer number 1 is where the pre-grouping robot places the parts on the virtual tray. And layer number 2 is where the non-pre-grouping robot picks up the part all together and places it on the outfit conveyor. iRPickTool assumes that the plane for the X and Y axis for the tray is on the same plane as the tracking frame for the conveyor where the tray is located. In our case, it's going to be the pre-grouping conveyor. And the pre-grouping conveyor has the same tracking frame as the in-feed conveyor, as we're going to see that later. We need to specify the origin of the tray. The origin can be in any arbitrary position, but normally it's going to be a position where it's easy or more convenient to teach. In our case, we're going to select the tree origin on the center of the part located on the first cell, as we can see here on this illustration. And then we're going to specify the X direction on the same direction as the tracking frame. And we're going to position the rest of the cells on the X direction of the tray. Since the tray is on the same plane as the tracking frame, we only need to teach the origin and the X direction. so we don't need to teach the y direction of the tray, but we're going to do that later when we set up the tray position on the infeed conveyor, as I show you here on this diagram. We're going to have the sensor on the infeed conveyor. We're going to set the tray position, and this is going to be our origin for the tray. For now, the only thing that we need to do is creating a table where we have the coordinates of the cells relative to the origin of the tray. One more thing that we need to consider is that we need to leave space between the cells, and the recommended minimum distance is 5 millimeters. This is for avoiding the collisions with the parts that we have already placed on the tray. If you don't keep this minimum distance, probably you're going to get an error, iRPK88. There is an invalid pregrouping setting. So the first cell is going to be on the origin of the tray. The second cell is going to be 26.5 millimeters plus 5 millimeters. That's going to give us 31.5 millimeters on the x direction. And then we keep placing the rest of the cells. And the table is going to look like this, where we have 4 parts on the layer number 1. Keep in mind that the order of the cell doesn't mean the order that the robot is going to place the parts on the tray. The robot decides by itself what is the most convenient order for placing the parts. We're going to go back to the iRPickTool setup screen. We're going to leave cell 1 as it is. The center of the part is going to be on the origin of the tray. And we're going to add more cells. We're going to select cell over here, and we're going to select add cell. This is going to be cell number 2. Over here at the bottom, we can change the position. And you can see as I change the position here, it updates the table. We need to add 2 more cells. And one more thing that you're going to notice that the model ID is going to be 1 for all the cells on the layer number 1. Now we need to update the reference cell. We're going to select cell number 1, and we're going to press set reference cell. We're going to get this message. We're going to press OK, and the reference cell is updated with cell number 1. And with this, we have set up layer number 1 on the tray. Now we're going to add a second layer. This layer is going to have only 1 cell, as the non-pregrouping robot is going to pick up all the parts together. We're going to select layer, and we're going to press add layer. Number of cells is going to be 1, and we're going to press OK. Now we are on the layer number 2. If we want to go back to layer number 1, we can select over here. For layer number 2, we're going to use model ID number 2, and we're going to consider that the parts are grouped together. The origin of the tray is still the same, so the center of the part as a group is going to be 39.75 millimeters on the x-axis. We're going to select cell number 5. We're going to enter 39.75 on X, and we're going to change the model ID to 2. And with this, we have a green check mark on tray number 1. If we go to the diagram, we are on this step on the configuration process. We set the reference cell, and we have this part already done. We're going to need this one later on the configuration process to set the virtual tray position. We're going to continue with the setup. Now we're going to select the conveyors. We're going to create a conveyor. We're going to call it infeed. We're going to create another conveyor. We're going to call it pre-grouping. And we're going to create another conveyor. We're going to call it outfit. Notice that every time we create a conveyor, it is adding automatically a sensor and a conveyor station. For the pre-grouping conveyor, we don't need the sensor. We're going to delete it. And we can rename the sensor number 3 on the outfit to sensor number 2. We're going to select the infeed conveyor. For line tracking type, it's going to be line. We are not using a tray. The tray is going to be on the pre-grouping conveyor. The model ID is going to be number 1. And we are not going to make any other changes over here. For the pre-grouping conveyor, what we're going to do, we're going to select in here when it says pre-grouping. We're going to press OK. And you're going to see that this part is grayed out because all this is going to be configured on the infeed conveyor. The same for the load balance. And over here, we can select the infeed conveyor is going to be infeed. And then we need to set up the virtual tray and the part type. We're going to select the outfit conveyor. The tracking type is going to be line. And we're going to change in here the model ID is going to be number 2. We're going to go back to the infeed conveyor. We are not going to set up the sensor for now. We're going to do that after the conveyor station. We're going to select the conveyor station number 1. We're going to rename it. This is going to be robot 1 infeed. We're going to press OK. Over here, we're going to select the robot. This is going to be robot number 1. Notice that as soon as we select the robot in here, we're going to have the operation conveyor station on robot number 1. Line tracking schedule is going to be number 1. And the encoder number is going to be number 1. And notice that the tracking frame is not trained yet. We're going to go to the pre-grouping conveyor. Over here, we need to add another conveyor station. We're going to select create. We're going to select conveyor station. And this is going to be robot 2 pre-grouping. This conveyor station is where the robot 2 is going to pick up the parts from the pre-grouping conveyor. And this conveyor station is going to be robot 1 placing the parts on the pre-grouping conveyor. So we're going to call it robot 1 pre-grouping. For robot 1 pre-grouping, the robot is going to be robot 1. Notice again that the tracking frame is not trained. And we have the operation conveyor station added to robot 1. We're going to select robot 2. Robot is going to be robot 2. Line tracking schedule is going to be number 1. And the encoder number is going to be number 1. And on the outfit conveyor, we can rename the conveyor station. We can call it robot 2 outfit. The robot is going to be robot number 2. Line tracking schedule is going to be number 2. And the encoder is going to be number 2. And you're going to see the robot 2. Now it has the operation conveyor station for robot 2 on the pre-grouping conveyor and robot 2 on the outfit conveyor. We can set up the operation conveyor stations. The approach offset is going to be a tool offset from the pick or drop position. In our case, the z-axis on the tool frame is going to be pointing up. So this one needs to be a positive number instead of a negative number. Be careful with that, you don't want to crash a robot. And also, we're going to enable the wait position. And we're going to do the same on all the operation conveyor stations. We're going to verify the operation. The operation for robot 1 in feed is going to be pick. And this is already grayed out. The robot 1 pre-grouping is going to be placed. The robot 2 pre-grouping is going to be pick. And the robot 2 outfit is going to be placed. We have a green check mark on all the operation conveyor stations. And the next step is going to be setting up the tracking frame on the in-feed conveyor. Since the in-feed conveyor and the pre-grouping conveyor are physically the same conveyor, we're going to set up the tracking frame on the pre-grouping conveyor. We're going to go back to the work cell. We're going to select robot 1 and we're going to open the teach pendant. We're going to verify that the tool that we're using is tool frame number 9. And we're going to do the same on robot number 2. We're going to select the in-feed conveyor. We're going to select the part carrier in-feed. We're going to go to parts. We're going to make the battery invisible. And we're going to select the calibration grid. Also, we're going to verify that the x-axis on the calibration grid is on the same direction as the tracking frame on the feed conveyor. That in our case is going to be the direction of the product flow on the conveyor. We're going to press apply and OK. We're going to select the pre-grouping conveyor and we're going to select the set tracking frame. This one says place a target to touch on the conveyor and press next. So we're going to press next over here. Origin point, move the conveyor until the target is in the robot working envelope and stop the conveyor. Check that the proper user tool is selected. Jog the robot so that the TCP touches the target mark and press next. So now we need to jog the calibration grid until it is inside the working envelope for robot number 1. We're going to select robot number 1. We're going to make the working envelope visible. And we're going to jog the calibration grid inside the working envelope for the robot. And we're going to touch the center of the calibration grid with a tool. We're going to press next. Now it says x-axis direction point. Move the conveyor to the downstream in the robot working envelope and stop the conveyor. Jog the robot so that the TCP touches the target marks and press next. and we're going to press next. So now, y-axis direction point, without moving the conveyor, jog the robot over the left side of the conveyor flow direction as much as possible and press next. And we're going to press next. It says the tracking frame and the encoder scale have been set up. Press next. And now we need to repeat the process for robot number 2. We're going to press next. Now we need to move the target on the downstream direction. We're going to press next again. And now we need to move the robot in the y-axis direction. And we're going to press next. So now the tracking frame and the encoder scale have been set up. Press next. And we finished with the configuration of the tracking frame on the in-feed and the pre-grouping conveyor. If we select the robot 1 in-feed conveyor station, you're going to see that the tracking frame is trained. The same happened on the robot 1 pre-grouping conveyor station and also on the robot 2 pre-grouping conveyor station. We're going to select the robot 1 in-feed conveyor station and we're going to verify this value over here for the tracking frame. The way that we're going to do that, we're going to position the calibration grid in the same position where we did initial touch-up, and we're going to measure the distance from the center of the calibration grid to the origin of the robot, and this distance should be very similar to the position of the tracking frame. And also notice that the coordinates of the tracking frame are relative to the coordinates of the world on robot number 1, not on the coordinates of the in-feed conveyor. Also, we can verify the tracking frame for robot number 2 should be this distance plus 1500 millimeters. So we select the robot 2 pre-grouping conveyor station. It's going to be the same position, adding 1500 millimeters on the Y. There is another way to verify the tracking frame, and that is opening up the Teach pendant. We're going to go to Menu, Setup. We're going to select Tracking. And over here, you're going to see that the status is going to be recorded. We can select this line and press Detail. And you're going to see here the position of the tracking frame. And you can do the same on robot number 2. If we go to the diagram, we are on this step, on the pre-grouping. We set the tracking frame, and from this point, we can go to the robot 1 in-feed conveyor station. We set the tracking frame, and we can set the boundaries. On the pre-grouping conveyor, we can set the maximum belt Y and the minimum belt Y. On the robot 1 pre-grouping conveyor station, we can set the generation line and the send line. And in the robot 2 pre-grouping conveyor station, we set the tracking frame and we can set the boundaries. And now we can go to the vision system and set the calibration and then the vision operation. I'm going to conclude with the presentation for this part of the video over here. Still, we have a lot of things to do. The next step is going to be setting up the vision calibration and the vision process. With that, we're going to be able to set the tray position, set the reference position on the sensor, and teach the robot position. And later, we can set up the outfit conveyor tracking frame, set up the miscellaneous parameters that we have on the remaining objects, and finally testing the application. So in the next video, we're going to continue setting up the iRPickTool with the pre-grouping option package, and thank you for watching.